So let's do page 39 here. Amanda's enjoying a hot air balloon ride over Winnipeg at an altitude of, I really like rulers for these questions. If you have squiggly lines, it just doesn't work. Like it's very messy, okay? So try to have a ruler or use your credit cards. You don't have credit cards, right? Don't have them. I'm just debit cards. Anything to make a straight edge, that's what I'm trying to say. Altitude, I don't know if you know what that word means. Altitude is height. So you're flying at a height of 2,500 feet. She spots the forks at an angle of depression of 34 degrees. So there's one angle of depression given. That is important. That should tell you something. At the same time, she spots, guys, listen to this. At the same time, she spots the Winnipeg's tallest building at an angle of depression of 27 degrees. Now, the question is, was she looking, is she up in the air and is she looking this way to one item, right? And then turning the other way, and is she looking down the other side? Or are we just looking in the same direction? I will make sure you know. You're not gonna have to guess, right? If you have to guess, that's not fair to you because it makes it a totally different question. But it says here, right, assume that Amanda's looking in the same direction. Okay, that is key. So let's sketch this. Some of you already have done so. If you need to make corrections, do it. So I will assume that Amanda is up here. Okay. At an altitude of 2,500 feet. So I'm going to introduce a height here.
You need to go Vincent, head to room 61 immediately. You need to go Vincent, attend your class now.
And then it's, there's a horizontal, this is the ground. For now, I'm just going to go dashed lines, right? And we know that this is 2,500 feet. So we're spotting the forks at 34 and the artist read at 27. Which one of these is closest to her? Like 34 is like you're looking, remember the angle of depression is measured from the horizontal. This is something I saw, some of you missed this. There's a horizontal, and so we're 34 degrees. You start from the horizontal, you're looking down 34 degrees, somewhere here. Okay, so this is your line of sight, and this is 34. That's where the 34 was supposed to go. And so this is forks. We're going to call that F for forks. And then the next one, the other building is at 27. So we're going from the horizontal. We're not going to go as far as 34, right? We're going to go 27. It's probably something like this. And this gets a little messy. I'm not going to lie. Okay. And I don't know, what should we call this? I'm going to call this R for artist read, and I can call this A for Amanda, okay? So you got to be creative sometimes. Then, so this is 27. So I always go out a little bit, like I don't have the angles at the same place to kind of distinguish them. So this is the scenario you're faced with. This is the scenario you're faced with. So what else do we know here? We know that the height, if there's a height mentioned, it makes a 90 with the ground. You're guaranteed this. Okay? You're guaranteed a 90 there because the height is always measured with 90 degrees to the ground or to a horizontal surface. We know that this horizontal line we introduced is parallel to the ground. Okay, we know this. Oh, parallel lines. I wonder if those four things are true. consecutive interior add up to 180, alternate interior are congruent. All of those things are still true. Sum of triangles equal to 180 is true. All of those things are true. Okay, so let's transfer as many angles as we can all over the place. Let's fill this up with angles. Different color for me. This 27. It's 27 there. Let me zoom into the diagram. This is 34. This is 34 there. I'm going to grab a different color. If this is 27, then what is this? Sorry, if this is 34, then this would be 146? Yeah. See how that works? Do I need this one out here? I'm going to argue I don't need it, so I'm going to leave it, right? But yes, you do have a straight angle. You could find something out here, but I'm not going to bother with it because it gets too busy. Let's also find what this little wedge is, just in case. You can approach it in two ways. You can go 34 minus 27, you get that. Or you have a triangle here. You just go 180 minus 146 minus 27. You get that. Regardless of how you do this, we have 7 here. So everything that's that's why I like different colors, because you know the pencil is what I was given from the question. Everything that's in color is being solved for by me. I'm adding, right? Let's find a little bit more maybe. What's this going to be here? It should be a 90 here. Between this one, this dashed line, and this one, it's a 90, right? So you can just go 90 minus 34, right? That would give us 6 to get to 40, so 56. I think that is enough now, right? We have enough information to get us started. What is it asking us now? Calculate the direct distance between Amanda and the forks. So what is it asking us for? Between Amanda and the forks, it's asking us for this side. I'm going to call that X. And I'm going to go up to my question and just say side X. I'm letting everyone know that's what, for me, that's going to represent the distance between Amanda and the forks. So let's go ahead and do that. So I'm going to do B right here. How should I approach this? So if X is here, I'm going to stick to this triangle right now. The 34 is across the 2500, correct? So that's my pair. And then I'm going to use 90 to solve for that X. Right, so that's what I'm going to do. I think for now, it's a good idea to draw out the triangle. I would encourage you to do that for now. Okay, this is X. This is 2500. This is 34. And then again, sine law is going to be your most popular tool in your toolkit. Sine law. It works for most cases. Okay, so we've got our pair here. It's going to be sine of 34. Just make sure when there's that many triangles that you don't mix them up. Okay, and then here's our sine of 90 over X. Can I use SOHCAHTOA for this one, Mr. Dirksen? Yes. If you remember SOHCAHTOA, this would absolutely be okay. And so we go X is equal to 2500 times sine of 90. Anybody remember what sine of 90 is? 1, yes. Too bad it's not 6, 7, right? Should maybe apply for some sort of legislation. that makes that happen. 4,470.73 according to my calculator and according to my key, so that's in feet. You circle that. That is your final answer. That's the direct distance between Amanda and the forks. Okay? Let's try this. See, I'm going to do that here. I'm going to try to make this work. What is C asking? Determine the direct distance between the two spots. Between the two spots right here. This is what it's asking for. So I'm going to call that Y. And I'm going to say side Y, right? Right next to the question. So I'm going to sketch this out. There you go. Let me transfer some information. This is 7. This is 146. This is 27. Y is here. I already know this one, right? This is 4,470.73. Right, you transferred this over into this triangle, so now we can use it. If you only had angles, you'd be stuck. You couldn't do anything with that. So, what law are we going to use? Mr. Erickson, we don't have one with 3 angles. This is AAAS, right? I know, but this is because we've solved for quite a few things. But remember, this side is across which angle? It's across this angle. So if you're not sure, grab one angle and travel out until you hit one of the sides. Then you know those are paired up. Okay, so sine of 27 over that. So we're going to start with that. Sine of 27 over 4,470.73. And then to find y, which angle do I need to use? 7, yeah. Sine of 7 over y. What am I expecting right off the bat when I solve for y? Is this side going to be longer or shorter than this one? Shorter, right? Because it's a smaller angle across from it. So things like that you need to watch out for. 4,470.73 sine of 7 divided by sine of 27. So you got to watch out. There's a lot of 7s there. You compute this, you get 1,200.12 feet. And I know that your teachers in the past told you, oh, if it's a word problem, you got to give me a full sentence. I don't need that. The province doesn't need that. You just need to tell us which one is what's answering this question. If we ask you to explain, to justify, to describe, yes, you need to use words. You can't get away without words there. But if it's just solving, you're done. Okay? All right. Could I find this side here if I wanted to? Yes, right? That would be the direct distance between Amanda and the Artist Reed building. So yes, I have enough information to do that. I just want to make a few notes. If you could go up here. Okay, note. Go ahead. Used alternate interior angles are congruent. We used sum of triangles equal to 180. And we also used straight angle is equal to 180, right? This was absolutely crucial before we even started solving for anything. One more thing. Is this the only way to solve this problem the way I showed it to you? No. There are several ways of solving this. Some students will, for example, to find this, I've seen students figure out, they use this big right triangle here. Make sure you pay attention to this part because you might encounter this. They use 27 paired up with 2500, right? So now you're dealing with this big right triangle. So they used the big right triangle to find the distance from here all the way to here. Then they use this right triangle here to solve for this. And then they just go this minus that to get this. So it is possible to do it in a different way. You just have to make sure you show me your work. And your answer might be slightly off, and we do not care about that. Okay, just make sure you show us every step of the way. So be mindful of that. If you're looking at a problem and then you solve it and you look at my key, it's different. That's fine. As long as we have the same answer, we're good. Where are we at? Almost 10. Okay, I'm going to ask you to go to 40. I'm going to sketch 40 and 41 with you, but then you're going to solve, okay? So I'm not going to solve these ones. I'm just going to give you the answers, and then I want you to do that for the rest of today. And I'm going to assign some more pages that are scattered over this booklet, okay? Fred and Agnes are 520 meters apart. That is important, right? Marie, if you need to go, go, yeah? 520. A plane flies overhead. They estimate that the angle of elevation is 60 degrees for Fred and 40 for Agnes. I'm just going to tell you how else could this have been worded. If they say that the angle of elevation is 60 and 40 respectively, okay? I don't know if you've ever read that. Respectively means what? It basically is telling you in this order that the characters are presented to you. So if they had just said 60, 40 respectively, that meant that it's 60 for Fred, 40 for Agnes, okay? If you encounter that. Assume that the plane is somewhere between, the plane is somewhere between Fred and Agnes. Very important, okay? So I don't need you to draw these to scale. It helps, but you don't have to. So let's see what we have here. We've got the plane up here somewhere. And we've got Fred and Agnes. It doesn't matter where you put the characters. I will put Fred here. And I'll put Agnes here. We know that the distance between them is 520. And we know that they're looking up. Sorry, angle of elevation is 60 for Fred. So if this is Fred, this is Agnes, we're going to go 60. This is 60. And we go to Agnes, and this is 40. Oh, who's further away from the plane? Fred is looking up higher, right? And Agnes is only looking up 40 degrees. So technically, Agnes is a little bit further away, right? Because she doesn't have to look up as high. So if you like that, if you like to see that depicted by your picture, that's why they make erasers, guys. Right? You just extend that line a little bit. I did that on purpose, by the way. You don't believe me, right? I know. I wouldn't either. But it happens. Okay? So this is 40 degrees. Remember, both of them are measured from the horizontal looking up, so we're doing good. Okay. Determine the distance between Agnes and the plane. So we want this distance. Maybe call that X. And what else? We want the height above the ground. That's H. height is going to be here, right? Like it's going to be, I'm not going to introduce it yet. You can do that later. I'm just going to tell you what the answers are. If you'd like to know, you're supposed to get 457.28 for the first one, and for the second one, it's 293.93. Okay. Let's go to the next one. If you missed this, you can come and take pictures later, okay? I just want to make sure you have a little bit of time to get started. Police helicopter is flying 400 meters above the highway. That's your height. Spots a collision at an angle of depression of 32 degrees. At the same time, the helicopter spots an ambulance at an angle of depression of 27. Assume the helicopter is between the collision and the ambulance. You're between the, so that is important. That's an important little piece of information. So let's sketch this. We've got our helicopter up here somewhere. And we are between the ambulance and the collision. So we're going to have the collision on one side and the ambulance on the other side. Notice this, angle of depression. So immediately, just if you look up here, immediately I will make a dashed line where the helicopter is, because the angles of depression are going to be measured with respect to a horizontal line. So the collision is at 62 degrees and the ambulance is at 27. So who's closer? The collision is closer, right? Not that it matters. Like, you're going to get it right no matter what. But so I'm going to do this. I'm going to measure 62 degrees. That's 45. 62 is about there. Okay, so my 62 is going to be towards the collision. I'm going to measure from there 62 degrees. And the ambulance is at an angle of depression of 27. And remember, the helicopter is somewhere in between those two sites. So I go up here. I'm going to measure 27. That's about 27 right there. Okay. And of course, they're both on the ground. So this is the ambulance. And the 27 goes up here. And where's the 400 going to go? It's the height, right? The height of my triangle. So you need to introduce that here. So this is 400. That is your diagram. So you've got two right triangles, and you've got a big oblique triangle. So you gotta possibly work with that. It says, how far is the ambulance from the collision? It's ultimately asking you for this. I'm not gonna give it a letter in this case. I'm just gonna give you the answer. Let me just look at it. You're supposed to get 997.73. This one might take you a little bit more work. Hint, use the height. If you use the height, you have to deal with a right triangle. You can't get away from that. Okay? Bring as many angles into the triangle as possible and try to solve it that way. If you are doing B, I'm just going to give you the answer to that as well. It's supposed to be approximately 2 minutes if you do the math. That takes you back to chapter 8. You got to convert your speed into kilometers per hour or meters per second, whatever the case may be. And it's a little bit of a review from the previous unit, so that's there. Additionally to this, I'm going to give you the pages that I've selected. Okay, so here is your homework. If you want to practice more, I would say, do I expect you to do all of them? No. I don't expect you to, like that's not like a must, but I would say you should do at least 3 of those questions that you find in between those pages. Okay, in addition to the ones I sketched, because I need you to read, sketch, interpret, solve. Okay, those are the steps I need you to go through. So I'm going to stop there. I will post the answer key from here all the way to probably 53. So you're just going to have to look for the answer that you want to find out. And that's it for today, guys.